Imagine measuring the average height of students in many different classes. Each class is different, but strangely the averages follow a normal curve. Why does this happen? This is explained by Central Limit Theorem. Today I will explain it using simple results and simulations. So the central limit theorem, so what does the central limit theorem say? So it says that when you take many random samples from any population or distribution and calculate their means, those means form a normal distribution or a bell-shaped curve, even if the original data is not normal. So what it says is that if we take a sample from a population or a distribution, and if we calculate the mean of that sample, and if we take enough samples to form a new distribution, then the new distribution will show the characteristics of normal distribution or a bell-shaped curve. So that is why this is so surprising and powerful. Now let's take a example of simulation to help you clearly understand what it is saying. So first, if you don't know what is a normal distribution, here is a normal distribution. It is also called bell-shaped curve. It is high in the middle and at the sides it is thinner. So for this for simulation, we'll take a skewed right curve, which is also called exponential distribution. So at first we take two samples or two exponential curves, and the distribution formed by by calculating their means is this distribution. Here we can see that initially the distribution is not quite normal. As you can see here, the normal is very thick in the middle and thin at the sides, but here it is not so, because it is skewed to the it is skewed and it is only thick to the left. So but as you go on increasing the number of samples, the distribution becomes more and more normal. So this is what the central limit theorem wants to say. Okay, so we know what central limit theorem says, but why does this happen? Why does this work? So why this works is because when you average the values, extreme highs and lows, also called outliers, cancel each other out, and random variations also balance each other. So the average becomes much more stable and follows a normal pattern. Again, let's see if if the central limit theorem holds true with other distributions, like for example here uniform distribution, which is a very flat distribution. So let's take a uniform distribution. This is a very flat distribution, and let's see if we take only two samples, the newly formed distribution by their means is not quite a normal distribution. It is almost uniformly it is also almost uniformly spread out from left to right. But if we go on increasing the number of samples, it goes on to become a normal distribution. So this is what the central limit theorem wants to say, and so we have seen that it works with multiple distributions. Now, what are the conditions for central limit theorem to work? Firstly, it is better that the samples may be random and be independent observations. And also, it is a rule of thumb in the community that we take a sample size of more than 30 or equal to 30. But but in practice, our sample size of 25, 26 already shows a normal distribution. Okay. So why is central limit theorem so important? Central limit theorem is important because using this we can calculate the margin of error, like say things like plus minus 3% with 95% confidence. So this is why it is clearly used in different sectors like polling, research, testing, and quality control. So what is our take on central limit theorem from this video? So the central limit theorem shows that when we take enough random samples, the distribution of their averages become approximately normal, even if the original data is not. That's why the normal curve appears everywhere in statistics, and that is why it is so important. Thank you.